So torque slip characteristics and double squirrel cage motor. See, first we'll see torque slip characteristics. So for every type of motor, we require to draw torque speed characteristics, speed torque characteristics. For DC motors also, we have drawn these characteristics. But for three-phase induction motor, we often call it as a torque slip characteristics. So instead of speed, we call slip characteristics. So what will be the effect of slip on the motor torque? So we'll get by these characteristics. So if you see, we can take slip on the x-axis and torque on the y-axis. And we have basic relations for their proportionality. The motor torque under running condition is given by torque T is equal to K constant S R2 E2 square पण असतो इथं divided by R2 square plus A square X2 square. So this is the relation for torque. If the curve is drawn between the torque and slip for particular values of rotor resistance R2, look at these are the various values of rotor resistance. Though we cannot change this resistance for squirrel cage motor, but we can change this resistance for slip ring motor. The graph thus obtained is called torque slip characteristics. This resistance we can change for rotor resistance, we can change for slip ring induction motor, but we cannot change for squirrel cage motor. So right. So in that case, this curve is applicable to both types of motor, but the resistance, different values of resistance, the curve applicable for slip ring induction motor. So look at that. The curve is drawn for the values of slip in between 0 to 1. 0 to 1. Look at the operation of motor will lies in between the value of slip will be 0 to 1. Look at what will be the condition. Whenever the value of slip is 1, that means just full screen it. Whenever the value of slip is 1, that means what? S is equal to 1. That means what? N. The rotor speed will be 0. So we have basic relation S is equal to Ns minus N by Ns. So this N will be 0, then Ns by Ns that will equal to 1. So slip is equal to 1. S is equal to 1 and N is equal to. So this point will correspond to the starting torque. So this is the starting condition. And when the slip decreases from 1 to 0.80%, 60%, 40%, 20% and around 0, this will be the running condition. These are all running conditions for the motor. Right? So maximum torque obviously will occur at a particular point in the curve where this maximum slip will be R2 by X2. That means whenever R2 is equal to X2, so at that time the running torque will be maximum. So this condition we already derived. Now look at the this equation says there are various parameters that torque is proportional to S on the numerator, but it is inversely proportional to S square on the denominator. So the characteristic will never be a linear. Linear characteristics nahi milenar because of reactance also present, and reactance is frequency dependent parameter. So it will also change. So on denominator there will be a S square x2 square, which is variable parameter, and on the numerator there will be slip itself. So now let us see why the up to maximum point the characteristics is increasing, and whenever the maximum torque occurs, the characteristics is decreasing. So these two sides we have to sleep. We have to study. So look at sleep is 0, then torque also 0. Look at what the relation we have. The sleep is 0, then torque also 0. So this is the starting point of the characteristics. So the curve starts from the origin, but at normal speed the slip is small. at normal speed, the slip will be very small, so that the parameter x into x2 can be negligible. We can neglect from the above equation as compared to resistance. So as resistance is constant, we know, then from the above equation, we are neglecting this numerator term. So this numerator term will be almost R2 square. Then there will be R2 will get cancelled. The torque proportional to slip. So what we have? Torque proportional to S by R2. And as R2 is constant, so we can say torque proportional to slip. So this is almost linear characteristics. So whenever the slip is increasing, so torque also increasing from the origin to maximum value. Look at it. Hence the torque slip curve is straight line from zero slip to the slip corresponds to the full load. As the slip increases beyond the full load slip, the torque increases and becomes maximum when S is equal to R2 by X2. So what this relation we have? So at that time the torque will be maximum. But if you see, after the maximum torque, the term S2 S square X2 square increases very rapidly. Because why? The slip is increasing. Look at it. Up to this point, the slip is around 0.5. This point. But up to above that point, the slip is increasing rapidly. So this term we cannot neglect. After the maximum torque occurred, we cannot neglect this numerator term, that is S square X2 square. So we have to take into account. Now the same formula will become torque P proportional to this formula. Will again we can write torque P is proportional to S by S square X2 square. We'll keep R2 as a constant and out of the side. So this S and 1S will get cancelled. So the torque will be inversely proportional to S. And as X2 is again constant. So torque is inversely proportional to slip. So that the characteristics is decreasing whenever the torque, the slip is increasing. So that's why the torque is decreasing after the maximum torque is achieved. So this is the reason. Thus, the torque is now inversely proportional to the slip. Hence, the torque slip curve is a rectangular hyperbola. Rectangular, it is like a rectangular hyperbola. The maximum torque remains same and is independent of the value of rotor resistance. Therefore, in addition to resistance, the rotor circuit does not change the value of maximum torque, but it only changes the value of slip at which the maximum torque occurs. Right? So this is the characteristics for torque slip characteristics of three-phase induction motor. So the ideal operation of the motor is between these two. Slip should never greater than 0.4 for the particular value of rotor resistance. Look at what will be the effect of rotor resistance on these characteristics. Another topic we have with respect to these characteristics. So what you can observe, if the resistance increases, then what we say, the maximum torque will be same, but whose occurrence will be dependent on the slip. Then in slip increases, the maximum torque also shifted. Right? So with respect to that, the different values of rotor resistance, there will be different values of slip at which the maximum torque occurs. Look at X2 जर आपण सेम ठेवला आणि R2 जर चेंज करत गेलो तर काय स्लिप पण वाढेल ना. The maximum slip SM will also shift their value. So this will be the effect of the rotor resistance on the torque slip characteristics.